So my problem this week is to show how the formula for the ring of charge is derived. So first we know that the formula for to solve a point charge is, or to solve the electric field of a point charge is E equals to KQ R squared. So we would want to find a way to relate that. So we're going to relate that using the arc of the ring. So we have the arc length formula, which is S equals to R theta. And then taking the derivative, we can say ds is equal to RD theta. Then we will take the derivative of the electric field equation to get dE equals to K dQ over R squared. And we know that we can say that dQ is equal to lambda ds. So then we can sub in this ds for this ds down in the dq equation, and we can sub this dq into this equation, which will give us K is equal to lambda R d theta over R squared. So this is kind of the magnitude of the electric field. We want to find the electric field in x and y components because this has more than one direction. So we can say that EY though is equal to 0 due to symmetry. And then because there's symmetry in the y direction in this ring. So we only need to find the x direction, and we know that to find the x direction we need the magnitude and multiply it by cosine theta. To find cosine theta, we would use the right triangle where this would be r and this would be z. And this is theta from this triangle right here. And then we know that the hypotenuse is square root of r squared plus z squared. And then we can sub that in for cosine theta because cosine theta will be z over adjacent over the hypotenuse, which would give us K equals to lambda r d theta over r squared times z over square root of r squared plus z squared. So then we still have this length right here, and this will be the length from the ring to the charge, which is the hypotenuse of the triangle right here. So then we would K lambda r d theta over square root of, or just r squared plus z squared times z over the square root of r squared plus z squared. R squared plus z squared. And then when we multiply everything together, we have dE is equal to kz lambda r d theta over r squared plus z squared to the 3 over second power. So from here we just need to take the integral of both sides, which would give us the electric field. The interval would be from 0 to 2 pi because we're doing the whole ring, which is a circle, and we'd get kz lambda r d theta over r squared plus z squared 3 over 2. And then when we finish the integral, we would get 2 pi k lambda r z over r squared plus z squared to the 3 over 2. And we would notice that the actual formula that we are given is E is equal to KQZ times, there's another z right here, and z squared plus r squared over 3 over 2. And that is due to the fact that Q is equal to 2 pi r lambda. And then we can we have a 2 pi, we have r, and we have lambda. We could sub that in for q, which would make it look nicer. And then bring it over here, we would have E is equal to KQZ, there's another z times k times qz over r squared plus z squared is equal to 3 over 2. And that is the formula to find the point from a ring of charge.